with some kind of polymers which act as a physical barrier for the microorganisms to attach. There can be a charged surface which create electrostatic repulsion and inhibit the microorganism to attach. We can make the surface with low surface energy which inhibits the bacteria to attach. So this is anti-fouling, where the bacteria or microorganisms are not killed, they are just inhibited to attach on the surface. Another mechanism is the biocidal mechanism. Biocidal means that microorganism will come, it will attach the surface and it will be killed. So again, there are two things. One thing is that the surface is releasing some kind of antimicrobial compounds which kills the bacteria. So, and another thing is that the it is not releasing, but when the bacteria, it will come in contact with that surface, the bacteria will be killed. So it is called contact killing mechanism. So once it will come in contact, then only the microbe will be killed. So these are the two mechanisms which actually works in antimicrobial coatings. Now, what happened if the surface is not coated with the antimicrobial coatings? So if it is not coated, what happened? The bacteria, if comes on the surface of the of that, it comes and sit on the surface. It will grow slowly. I will just take up just 1 second. So you see here, so this is planktonic bacteria. It came on the surface, slowly it grow. It actually secrete extracellular protein outside it, and slowly grows and make a biofilm. Now, planktonic bacteria, they are very, susceptible to antibiotics. If we take antibiotics, the bacteria will be killed. But once it forms a biofilm, like you can see here, that it is, the colony of bacteria, which is protected by a protein layer outside. So in that case, it is very difficult. Even there are many antibiotics which this biofilm resist. That means even if you use antibiotics, sometimes this infection don't goes off, and this biofilm get matured, and finally it again burst and release planktonic bacteria which contaminate the other surfaces also. So our purpose is, we should not reach the biofilm level. At the planktonic stage itself, we should kill these microorganisms. Now, I just want to convey a message here. For example, right now, I think particularly in this particular season, many children, they are actually getting viral infection, and doctors are actually giving them antibiotics. I think most of us are aware that antibiotic don't work on viruses, but still, uh, what happened, whenever the child is getting fever 1 or 2 days, we start giving them antibiotics, although those antibiotics will not work on those viruses. And because of that overdosage of antibiotics, what happened, the bacteria, they got resistant to the antibiotics. That means if you are giving them antibiotics regularly, slowly, those bacteria, they, even in the presence of that antibiotics, it will not killed, because they become resistant to it. They actually had some mutations in their structure, and next time when you give that antibiotic, it will not be able to kill that particular bacteria, and now we have to give, you know high dosage or some alternative to that antibiotics that can kill this new modified pathogen. So that is why we have to take care. We have to wait for starting this antibiotic dosage until or unless it is really required. And another thing is, if you are taking any antibiotic for any particular problem, complete your they give like 3 days courses there, or 5 days courses. It never, I just want to, through this presentation, I just want to give a message that if the doctor is recommending you with some antibiotic course, if it is of 3 days or 5 days or 7 days, complete that course. Don't stop in between, because that will be even more dangerous, and it can leads to even exaggerated or further strong infection in your body. So complete the antibiotic course if doctor has recommended you some. So you can see here that this is the prediction that the way our the antibiotic resistance is increasing globally. In Asia itself, you can see that by 2050, there are estimated around 47 lakh deaths in Asia itself. Because why? Because of those antimicrobial resistant strains, which we are getting because of the overdosage of antibiotics we are using. Now, this is the applications of antimicrobial coatings, where basically these coatings are we are using, particularly in the medical implants. Like we have the catheters, we have stunts, we have cardiac assisted devices, medical electronics, needles. We are actually doing the antimicrobial coatings on those implants to control the infection. In the food packaging, antimicrobial coatings are very much in demand. In textiles, in particularly in COVID, there are so much demand on antimicrobial fabrics, particularly for PPEs. Then even in our air conditioning system, we have this antimicrobial filters, which actually filters the microbes or kill the microbes. We have antimicrobial paints. I think in advertisement you have regularly heard of this, it kill bacteria, it kill microorganisms. So we have antimicrobial paints, we have coatings for the this door handles and all. Then we have the antimicrobial wound dressings. Wound dressings means the dressings which actually protect our wounds from infection. So this is the medical need for the antimicrobial coatings, and you can see here that every year in US itself, there are, if we talk about the medical devices, there are around billions of medical devices they have been used every year for various kind of problems. And the mortality because of infections in this kind of medical device, it is very high, in particularly for the heart implants, the heart assisted devices, or the cardiac, the mechanical heart valves, wherever the heart is involved. If that implant got infected, the chances of mortality is very very high. So that is why there is a high need of antimicrobial coatings, particularly on these medical devices. And you can see the global demand of these coatings in wound management. You can see here that there is a growth rate of 5.1% of this antimicrobial coatings. Even for catheters, the demand is very high. For the contact lenses, it is very high. For the dental implants, the demand of antimicrobial coating is very very high. So that is why we are working on this particular aspect. So this is particularly for the wound dressing materials. I'm telling the demand or the need for this. So there is a increase in chronic wound prevalence. There are two type of wounds. One is the normal acute wound, which we usually get while playing, or very small kind of cuts and all. These are called acute wounds, which actually don't need a very advanced kind of wound dressing material, because they heal if even if you use the any anti septic tube. Like even some people use Bernol, or some people use normal this betadine and all. So it will be cured. But if it is a chronic wound means which takes some time to heal. For example, the burn wounds are there, the diabetes patients. If there's a foot ulcer, it don't recover in 5-7 days. It will take sometime months to heal. Then we have the pressure ulcers. So these kind of chronic wounds, we need advanced kind of wound dressing materials. And the global market of these kind of dressing material, it's actually very high. And uh, right now, whatever